Have you ever looked at a giant skyscraper or a ship on the ocean and just wondered, how does it not fall over? It honestly feels like it should be magic, but it's not. It's physics. And today, we're going to pull back the curtain on the one hidden point that literally keeps our world from tumbling down. So let's think about this. Imagine you have a really weirdly shaped object, maybe something like a curved lamppost. There is one and only one perfect spot, a little sweet spot, where you could hold the entire thing up with just your fingertip. But where is it? And more importantly, how do engineers find that magic point for every single thing they build? Well, the answer to that entire puzzle is a concept that is as simple as it is powerful. It's called the center of gravity. Okay, let's really break this down. You know, any object, right, is made of countless tiny particles, and every single one of them has weight pulling it towards the ground. The center of gravity is just the average location of all that weight. You can think of it as the one spot where, for all intents and purposes, the object's entire weight is concentrated. If you can support it right there, at that exact point, you get perfect, stable balance. Now, you might hear a few different terms get thrown around here. Center of gravity, that's based on weight. Then there's the center of mass, which is more about motion. And the centroid, which is purely about the object's geometry, its shape. It sounds complicated, right? But here's the key thing to remember. For most of the stuff we deal with every day, a steel beam, a wooden plank, all three of these, they're in the exact same spot. So for our chat today, we can pretty much treat them as the same thing. Okay, so we get what this balance point is. But that brings us back to the big question. How in the world do engineers actually find it, especially for really complex shapes? Well, let's get into their method. I mean, if you look up the formulas for this stuff, your eyes might glaze over. They're full of these long integral signs, which is a type of calculus. And yeah, that's super precise, but it's not exactly practical if you're an engineer trying to design something quickly. So there has to be a better way, right? A kind of shortcut to solve this shape puzzle? Oh, absolutely. And it's a really brilliant technique. Engineers use what's called the composite bodies method. The whole idea is to take a big, complicated, intimidating shape and just break it down. You turn it into a collection of simple, friendly shapes that we all know, like rectangles and triangles and circles. It's basically like turning a really hard engineering problem into a simple jigsaw puzzle. And the process is this really elegant three-step puzzle. First, you just divide that complex thing into its basic parts. Second, you locate the center for each of those simple little pieces, which is usually super easy to find. And finally, you just average them all together with a weighted calculation, and that gives you the one single center of gravity for the entire object. It's clean, it's simple, and best of all, no complex calculus required. So here's what that looks like in the real world. This table here is showing the math for a metal plate. You can see its parts listed out. There's a big rectangle, a triangle, and a hole. They figure out the area and the center for each part. But hang on a second. Did you see that? A hole with a negative area? What is that all about? This right here, this is the secret sauce. This is what makes the whole method so incredibly powerful. To figure out where the balance point is when there's a hole or a cutout, you first just pretend the object is solid. Then you treat that hole as its own separate shape, but you give it a negative area. So when you do the final average, that negative value basically subtracts the hole from the math, giving you the exact center of gravity for the final complicated shape. It's such a clever little accounting trick. So finding the balance point is one thing, but knowing where the centroid is, well, that unlocks some truly surprising design secrets. Think of them as engineering superpowers. Seriously. This one little point gives engineers an almost predictive power. It's a total secret weapon. Let's look at two of the incredible abilities that it unlocks. First up, we've got a concept that, I promise, sounds as delicious as it is useful, the donut theorem. Okay, its real name is the Theorem of Pappus and Guldinus, but come on, donut theorem is just way more fun. This theorem is basically a cheat code for geometry. It says that if you want to know the volume of any object that's made by spinning a 2D shape around an axis, like spinning a circle to make a donut or spinning a rectangle to make a big storage tank, you don't need to do any crazy math. All you have to know is the area of that flat 2D shape and where its centroid is. The volume is just the area multiplied by the distance that centroid travels. It's an absolutely mind-blowing shortcut. All right, for our second superpower, we're going to go from donuts to dams. So how do you design a wall that can hold back the unbelievable crushing force of billions of gallons of water? You guessed it, the centroid is the key. So here's the challenge, right? Water pressure isn't even. The deeper you go, the stronger it gets. So at the bottom of a dam, the force is immense. This creates this huge, spread-out force that is just constantly trying to push the dam over. So how on earth do you fight that? The solution is just brilliant. Engineers can take that whole messy, distributed pressure and treat it as one single resultant force. And where does that massive force push against the dam? Exactly. It acts through the centroid of the pressure distribution diagram. By knowing that one single point, the center of pressure, they can design the dam's structure to perfectly resist that force and stand strong for centuries. So whether we're talking about balancing forks on a glass or designing continent-spanning bridges, this one single concept is the fundamental blueprint for stability. The center of gravity is what defines an object's perfect balance. It is the absolute key to designing stable structures, everything from the chair you're sitting in to the tallest skyscrapers. It's what governs how cars and planes move without tipping over, and it gives us the power to calculate and control these massive, almost unimaginable forces like water pressure. It is, quite simply, hiding in plain sight, everywhere. It really all boils down to this one core engineering principle. No matter what the force is, its line of action, where it effectively pushes or pulls, always passes through the geometric center, the centroid. If you understand this one point, you understand the secret to stability. So the next time you see a crane lifting a massive beam, or you see a leaning tower that somehow just doesn't fall, or even something as simple as a fork balancing on the rim of a glass, you'll know the secret. You'll be able to see that invisible point, the center of gravity, just quietly holding everything in perfect balance. So the real question is, what are you going to see now that you know where to look?